Hi and welcome to Advanced Routing Protocol Concept. Today we will be discussing the protocol called OSPF. This protocol uses the shortest path first algorithm to ensure efficient data transmission. OSPF basically stands for Open Shortest Path First. As you can see on my Cisco packet tracer, I have a small network setup with routers, switches and end devices, which I would have labeled with their relevant network and IP address is. So before we go into OSPF, we will need to configure the routers. So we will go into router 0. I would open the two of them so we could do the two of them together, and we'll go into our command line interface. Right, command line interface, we're going to do the same thing twice. Right, so on router 0, which is router on the left hand side, we have an serial and an interface, and we're going to configure that. Enable config T int, the serial number or the serial is 0/0/0, IP add 172.168.20.1.255.255.255.0. Because there's a clock on the side, we need to set a clock rate. I am going to set my clock rate at 72,000, and then we're going to run a command no shut, and you would have seen that that serial has now went down. If we go on router 1, which is the router on the right hand side, and we do the same thing, we would see that that serial will now be up. Enable config T int, the serial for that side is FAS 0/0/0, right? So that is here, S 0/0/0, IP add 172.168.20.255. No shut because there's no clock on that side. We do exit. You would have noticed in the background here, the serial on the left hand side now went up, so that whole connection between router 1 and router 0 and router 1 is now connected. So for router 0, which is on the left hand side here, we are now going to configure our interface. Right, so interface on this side is FA 0/0, so do an int FA 0/0, IP add 172.168.40.1.255.255.0, and we run a no shut. Once we have completed doing our configuration on our serial and our fast Ethernet interfaces, we need to run a command that would allow us to save what we would have done before, and this is the command that I'm currently typing. Right, and as I said, we are going to do the same thing on router 1, so I'm just going to move this across. So you would see FA 0/0, we're going to configure that, so int FA 0/0, IP add 172.168.100.1.255.255.255.0, no shut, and you can see it went up. Exit, copy. We're gonna save again on this side. Startup config. Right, so to make sure or to see if our interfaces are actually up, we can run a command that says shows IP in brief. So I can show you that here. Show IP int brief, and you will see that fast Ethernet 0/0, which we have here, and S0/0/0, which we have here, is up, right? Yes, status up. And if we do the same thing on router 1, show IP int brief, we would see the same thing here, right? The two that we would have configured is currently up. So now on router 0, we're going to start the OSPF. So we need to go back into the terminal. So we're going to do config T router OSPF 1, and we're going to add the networks that we have here, 172.168.20.0 and 172.168.40.0. 172. And we have it in an area 0. And then we'll just press Ctrl Z, and again we're going to save those commands that we'd have just run. We're going to do the same thing on this side again. As I said, everything we do on the right side, we have to now do on the left side. So going back into the terminal, config T router OSPF 1 network, but on this side we'll be using a network on top, which is a 172.168.20.0 along with a 100.0. So it's 172.168.20.0, 0.0.0.255 area 0. Right, and Control Z, and again copy what we have just done, so to be saved, right? So to ensure that OSPF was done, you would have seen that it has loading to full loading done, but just to ensure, we can do a command which just shows IP OSPF int brief, and you would see that it's done, and it's connected through the IP address. The serial 0/0, which is on this side, is connected through the IP address on this side and on this side. And if we do it on this router 0 on the left hand side, we would get the same response. OSPF int brief, int brief, right? It gives us the same response. So now we need to ensure that our PCs could work or ping each other. So we need to add IP addresses to them. So we are going to each PC and go into the IP config and give each of them IP addresses. 40.2, 40.2. One 168.40.3. 172.168.100.2, 172.168.100.1, to the 168.100.3, and now this will be 172.168.100.1. Right, so I would have added an IP address for all the PCs, and everything should be connected correctly. So I'm now just going to fast forward the time to ensure that's connected and everything could feed each other on each other. And now I'm going to go back into PC 0. Remember, PC 3, which is on this side, is this IP address. So I'm going to try to ping PC3 from PC0. So I'm going to go into PC0, go on the command prompt. I'm just going to type ping 172.168.100.3, and once all the steps were done correctly, your two PCs should be able to ping each other. Nice. As you see, everything was done correctly and it could ping each other. Now I'm going to do the other way around, from PC3 to PC0. So we're going to do ping 172.168.40.2, and you can see automatically it went, so nothing was lost and all the packets went through. Another way to test if your PCs are working, we could come here and send a simple PDU from, let's do it differently, so from PC1 to PC2, and you can see down here it would have failed the first time. So let's try again. PC0 to PC3, successful. Let's try again. PC0 to PC2, successful. PC1 to PC3, successful. One last time, PC1 to PC2, and we'll have to scroll a little bit, and it was all successful. Thank you, and see you again in another video where we'll be talking about EIGRP. Stay tuned.